Okay. Whew. Okay, now that I'm recording, I can say this. I've posted test 2 practice and test 2 practice solutions to the class Moodle page. Please do not look at the solutions until you've done the practice. I hesitated making these visible at this point, but I thought that I would because people work at all different paces, and I want to make sure that I accommodate as many people as I can. What I want to say though is you're not going to have the solutions in front of you on the test. So it's probably better for you to work on the test practice to completion before you take a glance at the solutions. Okay. But I did do this yesterday. I stayed at work until I was done because I wanted to get that to you as soon as possible. Okay. So that is one announcement. My other announcement is that our test number 2 is next week. In an ideal world, I would love to have it next Wednesday, so a week from today. But I know that life isn't always ideal. And so if we need to bump it to next week on Friday, we can certainly do that. It kind of depends upon all of you. Actually, you know what? I'm not even going to say that. I'm not even going to say that. Let's just do this. Test 2 is next Friday. That makes most sense. Okay, that'll give me time to answer questions. It'll give us time not to rush through anything. So test 2 is next Friday. Here, please. Okay, cool, awesome. All right, so what I want to also say is that lesson 8 is due tonight by midnight. Lesson 9 is due Friday by midnight. We're going to be finishing up lesson 10 today. So I'll say lesson 10 will be due next Wednesday by midnight. I'll assign that at the end. And then we still have lesson 11 left to cover. Now, the ideal is that you're going to do lesson 11 before the test. That's the best way to prepare for any exam, is to practice, 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 and more practice. But I will still give you the full week just because I made that promise at the beginning of this semester, and I'm not one to go back on things like that. So we'll just see when we finish it so that we know when the test, so that we know when the due date is. I will say that activity number 6 is due this Friday, either in class or via email. Okay. I will not have another class activity before the test because you have the test practice that I want you to be focusing on. And I don't see the point of like piling on assignment after assignment. Sound good? Okay. Cool. Yeah, I think it's just best. Let's just put the test next Friday. That'll give us some breathing room. And then next weekend, other than maybe wrapping up lesson 11 online homework, you won't have any math homework to do. And I think it's daylight. I don't know what you call it, but I think it's when we switch our clocks too is next weekend. So, all right. So, cool. Thumbs up. Awesome. Awesome. Okay. So, this is going to be fun. You're like, of course, we're in math class. Of course it's fun. And I'm smiling big because your cat Wally's really cute. And I just like, I didn't go home last night, so I miss my cats. And so I'll get to go home tonight. And go, oh, okay. So we were talking yesterday about looking at z-scores, okay? So we were talking about how many standard deviations a particular value is from the mean. And we saw that we did that using z-scores. And the beautiful part about this is the fact that we could then literally compare apples and oranges, because what we did is we standardized the way that we measure them so that we can make some fair comparisons. Okay. And we saw that z, if I don't use the formula, but I use words, maybe this will help some people. Data value minus the mean divided by the standard deviation. Okay. And we saw also that when your data value is equal to the mean, obviously it's no standard deviations away from the mean. Okay. But we saw that when our data values are greater than the mean, they're going to be positive. When our data values are smaller than the mean, they're going to be negative. And the further away they are, the more quote unquote unusual they are. Okay, so what I want to talk about kind of takes us to the end of lesson 10 and is a really nice segue into lesson 11. Now, what I want to say in terms of the fact that we do have one more section left to cover before the test is it's not a huge section once you get the hang of it. It's a lot of it's on a calculator. So you're going to want to bring your calculator and know how it works. But as always, from now on, I bring both versions of the calculator to class. So I promise you, I will show you and you'll have these on a recording. Cool. Okay. But this leads into some really cute stuff. So one of the things we like to talk about is how many standard deviations something is from the mean. Okay. And I claim this is something that's actually used a lot in the quote unquote real world. I don't really love the term the real world because real is relative. Yeah, I'll get into this in a moment. There's a particular court case that I always like to mention where they actually talk about number of standard deviations from the mean. Okay. But one of the things we want to talk about is how many standard deviations things can be from the mean. So as I showed you, another way to represent the mean is this Greek letter mu. Okay. And one thing that we like to talk about is when something is one standard deviation from the mean. Okay. In other words, we take the mean plus the standard deviation, and we take the mean minus the standard deviation. Using those Greek symbols, mu and sigma, essentially what we're saying is mu plus sigma and mu minus sigma. So something can be within one standard deviation of the mean if it's a certain distance above or a certain distance below. Okay. Now I'm going to keep with this kind of sort of number line. But another thing that people can talk about, usually talk about 1, 2, and 3 standard deviations from the mean. We can also talk about being 2 standard deviations from the mean. And you can say, well, that's the mean plus the standard deviation plus the standard deviation. But I think you'll grant me that we can simplify that to say mean plus 2 times the standard deviation. And we can also do it minus. So then this interval looks like the mean minus 2 times the standard deviation and the mean plus 2 times the standard deviation. And I could put that on this graph too. So if this is the mean, to be within 2 standard deviations above the mean, it means that your value's somewhere in here. And then similarly, your mean minus 2 times your standard deviation, it means that your value's somewhere neath in here. Okay. And then finally, we can talk about 3 standard deviations from the mean. To be outside of 3 standard deviations of the mean is extraordinarily unusual. Okay. So when you're talking about 3 standard deviations from the mean, what we're talking about is the mean minus 3 times your standard deviation and your mean plus 3 times your standard deviation. Now, when we get to normal distributions in the next section, you're going to see that we have approximate percentages, but we're not there yet. Okay, so how do you do these computations? Well, friends, it is literally just adding and subtracting. So let me take you through a real concrete example. Okay, so what if I told you that a test had an average of 82? Wow, that's a really high average. I would actually jump up and down if my tests had that high of an average. I'd be like, oh my God, my students are awesome. Okay. With a standard deviation of 2.3. What I want us to do is find the intervals within 1, 2, and 3 standard deviations from the mean. Now you might ask why, and I'll actually give you a little motivation here. But let's make sure we can all do the computations. Now, first off, we have our class average is 82. And we have a standard deviation of 2.3. At first glance, that's a really small standard deviation. Okay, what we're saying when we talk about the standard deviation is on average, each test score was about 2.3 points away from 82. So that's a really tight cluster. That means that people scored pretty contained here. Okay, so how do we do this? Well, the key thing is this is our mean and this is our standard deviation. So if I want to talk about one standard deviation from the mean, I will literally take my mean and add and subtract my standard deviation. Now, as you might remember in math, whenever we write intervals, we always put the smaller number to the left. Think about your number line. As you move to the right, the numbers get bigger. So on the left, we'll have 82 minus 2.3 and then 82 plus 2.3. Well, if you do this arithmetic, you're going to have 79.7 on the low end and 84.3 on the upper end. Literally, I just added and subtracted. Okay, if there's a question, please ask. Now, if we want to do 2 standard deviations from the mean, Literally what you do is you take the mean and add and subtract 2 times the standard deviation. And I claim if you do this, you're going to get 77.4 and then 86.6. And finally, 3 standard deviations. You're going to take whatever the mean is and add and subtract 3 times whatever your standard deviation is. And you're going to get 75.1 and 88.9. Are there any questions on how you would compute any of these things? All right, so I had mentioned that some folks like to grade on a curve, like a bell curve, okay? And here, I'm just going to put these values on this line here. So I have 79.7, 77.4, and 75.1. And then going up, I have 84.3, 86.6, and 88.9. So if, you have a class where they like to distribute the grades based upon standard deviations, usually being within 1 standard deviation of the mean would be those are all the C's. Okay. But if you're between 1 and 2 standard deviations of the mean, those would be your B's. And then up above, those would be your A's. And similarly, those would be your D's and then your F's. Now, should someone get an F if they got a 75.1? I think not. Okay, but these are just made up numbers. But this is where people can use talking about the number of standard deviations from them. Are there any questions on this? Okay. So the long and short of what I want you to get out of this section, other than talking about standard deviations, is number 1, the Z-scores. That allows us to compare things that are measured on 2 different scales, okay, to make some sort of comparison. The other thing that I want you to get out of this section is that when we talk about the standard deviation, what we're doing is we're talking about how spread out is your data, okay? Because if our data is extremely spread out, in other words, if we have a big standard deviation, our mean is not that good of an indicator as to what our data set showed. Whereas if our data is really compact, kind of like here, this mean is a really good, good estimation. So what I want to do now is share my screen again, just for a second. Cool. All right, so what you all should see now is my open math. Looks a little different than yours, but don't sweat it. What I'm going to do is take you to lesson 10. And since we finished that section, I'm going to assign the homework to be due a week from today. God, I can't wait to see what a week from today is. Holy smokes, it's November 2nd. All right. So your homework is due a week from today. Now, what I want to show you in this lesson 10 homework, and what I want to say about all your homework is please do not wait until the day it's due to work on it. Because when I wake up in the next morning, I go to bed at, honestly, I get in bed at 8:30 at night. I'm so lame, but I love to read until I pass out. And so when I wake up in the morning, especially like the night before our homework assignment is due and there's a ton of math questions, it's like, oh, don't ask me the night before, I'm already in my beddy time. So please work on your homework sooner. Don't let it pile up. But what I want to say here is as follows, just so that I can guide you all through. And Riley, yes, I'm going to be doing more examples like that, but I'm going to do them in the context of the next section because that's where they really come about. Okay. So what I want to do is just very quickly show you, like this first question, you're literally just can enter these into your L1 list in your calculator, okay? And hit that 1-var stats like you did in lesson 9. And instead of reading off your mean or your median, what you're going to read off is your SX, okay? Notice I'm going through and I'm telling you how to do each of these problems. Okay, this one, Kyle and Ryan take entrance exams. You want to compare these two values. Okay. So what you're going to do here is just compute the z-scores. Whoever has, in this case, a higher z-score is probably more likely to get in. Okay, so number 2 is a z-score question. Number 3, this is another one that you're just going to literally plug into your calculator and do the 1-var stats. From that, you can read off your mean, you can read off your median, and again, you want to use SX, the sample standard deviation. The mode, I'm not sure that calculators do that, but that's just the most frequently occurring data value. And this is pretty manageable to look at, so we can just kind of read that one off. All right, question number 4 is another one where you compare z-scores. Okay, so they give you 2 children with various heights. They want to know which one's taller. They say this is not a trick question. It's a very literal question, but then they want you to compute the z-scores of each of these children's heights and then answer which is taller relative to their corresponding populations. So that's another z-score question. This is the biggest pain in the butt question, and I'm really sorry about it. But essentially, what you're going to do is you're going to enter this list and find the mean and the standard deviation. And then you're going to do the second list and find the mean and the standard deviation. And then they just ask which mean is higher and which data has the larger spread. Why is this one a pain? It's a pain because you've got a lot of data values to enter into a list. So there's a lot of room to make typos. Okay, I don't have you enter lists on the test. Okay, so in lesson 9 and lesson 10, I do not have you enter the lists into your calculator and then find the mean and the standard deviation and the median on your calculator for the test, because it's too easy to make typos and it's a homework question. It's not really like a test question. All right, so number 6 is similar to the heights of the children, but now we're talking about 2 runners. Okay, so again, you're going to compute the z-scores and answer that question. Question number 7, I love this question. It's just asking you to interpret what the standard deviation means. Okay, and it's literally just drop down menus. Here they give you the two z-scores and they want to know which one is more unusually large. You're going to want to divide those obviously, but to get a value. But again, it's just comparing z-scores. All right. Question 9 is another calculator question. You're going to enter this in. This is people's grades on their final exam in a stats class. And so they want you to find the average. Okay. And then they're going to tell you, well, the average on the midterm was this. Did they do better on the final or the midterm? And you're just going to compare that value there to whatever you computed here. And then they're going to ask you to compare the standard deviations. Again, this is literally just a calculator question. And then number 10, this is another z-score question, etc. Okay, notice in this, in this homework assignment, I don't have you compute the number of standard deviations from the mean like the last example that I did, because it's really more relevant in the next section. It's just a very beautiful segue. Okay, so I have now gone through how to do each of these online homework questions. Okay, so my strong recommendation is do them while they're fresh in your head. Cool. Awesome. All right. So what I want to jump into right now is really just the background vibe of where we're heading in our last section. Okay. Does that sound like a good plan? Okay. Now, I want to tell you that anybody who is going on and taking Stat 216 after this, normal distributions are one of the biggest carryovers. Okay, they're really, really, really important. Okay, we talk about them a ton in our stats classes. Okay. So what I'm going to be doing here today is just kind of giving you the background scoop of what we're talking about. Okay. So one of the measures of central tendency that you may have noticed, I've been just kind of like pushing it aside, is the mode, right? The mode is not used that often in practice, but it is something that we're going to hone in on a little bit now. Okay, the mode is the most frequently occurring data point. Okay, and as we saw, you can have one mode, you can have many modes, or you can have no mode. Okay, when everything occurs the same number of times, you have no mode. Okay, so suppose I wanted to look at the frequency of, I don't know, what kind of pets people own. Okay, you got me in a one-track mind here. So we can talk about cats, and suppose I measure how many people have cats. What this is going to be is this is going to be a frequency chart. So you've seen box plots before, histograms probably. If you look in the newspaper, they tend to graph these things quite a bit. They're very, very useful. So suppose we looked at the frequency of how many people owned cats, and it was right about here. Okay, then we can talk about dogs. Should we have more or less people own dogs? More. I knew you'd all say that. Or I should say dogs own us. Okay, what's another pet people have? Birds, okay. That's probably not as common as cats, but if you have a cat, you probably don't have many birds left. And what's another pet? Fish. Maybe, oh, pretend this is a straight line. Okay. So suppose this is a graphical display of the number of pets that people own. Okay. What's beautiful about this? Okay, these are called bar charts here. What's beautiful about this is you can look at it and get immediate visual, can't you? What is the pet that most people own, according to this? Fish. That's because they're low maintenance, right? What is the pet that's least frequently owned? Birds. Okay, again, you can look at this because you could say, well, if this measures frequency, the tallest one is the most frequent, then this, then this, then this. Okay, now in this sort of situation, we wouldn't really draw a curve that goes across this. But the point that I want to make is, in this case, we're looking at categories. Okay. But we can also look at other things. So something else that tends to be measured, and I'm not into it because I think that these things are silly, kind of like I mentioned yesterday, that I think standardized tests are rather silly, just in the sense that they're not equitable by any stretch. But another thing that people measure are IQs, okay? And it turns out that like the average IQ is deemed to be 100, okay? And what we can do is we can look at various IQ scores, right? So as this gets bigger, you know, you go to the right, and smaller, you go to the left. You would expect that most people are clustered in the middle here. And usually when we talk about this, we talk about it in intervals. Okay, we don't do exact IQ scores, but we do intervals, like maybe 100 to 105 is what this interval is. Maybe that's the most common one. And then from 105, so this is 100, this is 105, this is 110. Maybe there's fewer people there, okay? And you can graph these things in intervals. Now, sometimes data makes it so that not everything is perfectly balanced, but what I want to do is I just want to take a few of these. Okay, so what we can see here is we're measuring frequency. This happened most often. In other words, our mode is right here. Okay. And then as our values get bigger, so again, this is like 100 to 105, 105 to 110, 110 to 115. So we're grouping the scores, kind of like what we saw with those group tables, okay? But if I was now to draw a curve connecting the tops of this, that's a pretty nice little shaped curve, isn't it? Like this one's like all over the place, but this is a pretty nice curve. And notice it's highest in the middle, and then it tapers down. When you have a nice looking curve like this, it's called a normal distribution. We call this a bell curve. And there's just going to be a few things that I say to you today about this, okay? It turns out that given enough data, many things follow a distribution that looks like this, okay? And what do we mean by a distribution that looks like that? with normal distributions, they have the following characteristics. The mean is equal to the median, which is equal to the mode. That is powerful. Right? I mean, what we're saying is the peak is exactly at the middle value, right? Peak is mode, middle value is the median, and those both take place over the mean. So our average value is equal to the middle value, which is also the most frequently occurring value. That's right smack dab here. Okay, now, do things in real life exactly follow a normal distribution? No, but it is absolutely astonishing that given enough data, this is called the law of large numbers, and you'll cover it in statistics, okay? Given enough data, things do follow this. Another thing that we are given is that most of the data is clustered about the mean. In other words, if this is our most frequently occurring data, the next most frequently occurring data is going to be right by its side. Okay, and then it tapers off. So this kind of gets at when I was talking about how the further away you are, the more from your z-score or z equals 0, the more unusual it is. That's what I mean by it. Okay, again, these heights measure frequency. So notice the higher frequencies are closer in. Another thing, this bell-shaped curve is what we call symmetric about the mean. And by symmetric, we mean mirror image. Okay, so essentially what we're saying using this terrible picture that I drew is if I could somehow fold this along the middle here, what happens on the right is nearly what happens on the left. But given that, another really powerful thing about that, since the mean is the same as the median, it means that 50% of our data is above the mean, and 50% of the data is below the mean. Right? Because that's what it means to be the median. So whatever happens on one side happens on the other side. And finally, the area under what we call a normal curve is 1. You're not going to be asked to compute the area under a curve. That's something you do in second semester calculus, actually, is find areas under irregular regions. But this is an important factoid. So pretend this is a normal curve. I never can draw them very well symmetric, but okay. Right here, my friends, is our mean, median, and mode. I know that 50% of my data is larger, 50% of my data is smaller. Okay, notice the height of this is the highest here precisely because of this characteristic, that the mean, sorry about that, is equal to the median, which is equal to the mode. Okay, so your mean is smack dab right here in the middle. Y'all with me here? Okay. So the next, do I have time? This is probably a good place to stop. I'm not done introducing these things yet. I want to talk about the shape of these, because one of the other things that I want to say before we start getting into computations and stuff is that these can take on a lot of different shapes. Not that I'm good at drawing, but you can have a really flat normal distribution. You can have a really tall and thin normal distribution. They can take on a lot of different shapes. And I want to talk to you about what determines the shape. But I think that's a good thing to continue next time. So yeah, I will see you all on Friday. Thanks.